All right, here we go with problem 2. We got a continuous function f from -4 to 4. The graph of f is shown above. Okay, portions of 3 parabolas. The graph has horizontal tangents at -1/2. So that's at -1/2. This is at 1/2, and that is 5/2 or 2.5. Okay. It is known that you have a formula for this particular parabola right here, okay? And the areas of region A and B bounded by the graphs of f and x are 3 and 5. So this would be 3 and this would be 5. Again, some people like to label it as -3 because it's below. That's up to you on how you do that. Let g be the function defined. Okay, how many problems like this have we done? A function defined as an integral. And then letter A says find g of 0. So g of 0, I would show my work, is going to be the integral from -4. I plug in 0 for x of f of t dt. So that is going to be, I've got to figure out the area from, it is low to high, which is good, makes sense. Above the x-axis will be positive and below will be negative. So I would break that into 2 triangles. And this first triangle here would be 1/2 a base of 2, a height of 3, plus 1/2 base of 1, height of 3. And then this guy is below the x-axis, so it would be -3. Now, technically speaking, if that was, honestly, I would just stop there. Because once you're down to algebra, you're good. So they would give you full credit for that right there. I will say this one is not that hard to figure out. And as I move to letter A, or the second part, I might need to get that number. It almost takes me less time to figure out that number, especially when I have a calculator, to double check myself, than to write that all out again. So yes, you can leave it like that, but it's not too hard to see that, oh my gosh, those cancel, that's 3. So this whole thing is equal to 3/2 or 1.5. And the reason I say you might want to get the number is because when you're doing g of 4 and you have to go from -4 to 4 of f of t dt, again, I'm going to kind of tell my grader what I'm doing. I'm going to be like, okay, that's going to be equal to, okay, that's fine, g of 4. This integral, I'm basically going to break up. And I'm kind of telling my grader what I'm doing. So I'm like, okay, I'm going to go to 0. And I have that answer in letter A. Then I'm going to do the integral from 0 to 1, which I know. And then I have to do the integral from 1 to 4 of, and I could even put f, or I could even put in this equation, because that's what I have to do. Okay, now here's the deal. So here is why I said it takes me a lot less time to figure that out in my head and just put 3/2 for that. But yes, if you copied all of this and put it right in for there, that's fine. So 3/2 plus 0 to 1 was 5. Now here's where this question and how your AP exam is going to be on this year because of the craziness. This was intended to be a non-calculator problem. So, you know, you would have to take the antiderivative by hand and evaluate, etc. By no means would you do that because you're going to have a calculator and you're going to plug that in. What equals 4.5. Again, I'd leave it like that. There's no need to simplify, certainly, if this is my last one. And so there's my question, or there's my answer. So g of 4 would be equal to that. Where the points came in, you got 1 point for g of 0. Again, whether you left it like this would be full credit, or if you put 3/2. But if you have this and you miss out and you put 2/3 because you just got silly and you meant to put 3/2 and put 2/3, y'all, you don't get the point. That's why I'm saying, boy, just learn to stop. Know when to stop. And then figure it out if you need it for a later problem. That's something different. Okay, this guy, so that was worth 1 point, g of 0. G of 4 was, again, it certainly wouldn't be this point count on this test because did you break up the integral was worth 1? You know, did you break that all up? They gave a point for the antiderivative of this because it was meant for you to do it by hand, which obviously you're not going to do on the test. And then 1 was for the answer. So it was, there's kind of a point in there that doesn't make sense for this year's test, but there you are. All right, let's get letter B. And I'm going to leave that part up there because I'm going to actually refer back to letter A. Find the absolute minimum value of G on the closed interval -4 to 4. Oh, please listen to me right now. Okay. Absolute minimum, closed interval. I'm hoping you think candidates test. If the values are pretty easy to find. Now remember, what are the candidates? The candidates are endpoints in any time where the derivative is equal to 0 or undefined, which there's a lot of places in there. But you know, I'm going to erase all this so you can just kind of see it cleanly. Because they specifically ask for the absolute minimum would have to occur at a local minimum or the endpoints. So here's my point. When they ask you for a specific one, I want you to write this. Write the sentence. Absolute min occurs at endpoint or when G prime, this is the first time I'm writing the word G prime. Notice I didn't do that in letter A. And I'm going to tell my grader, hey, grader, I know that G prime is equal to F. Again, that second fundamental theorem occurs at an endpoint or when G prime, which equals to F, changes negative to positive. See, I'm only looking at candidates that really matter. Okay, so my candidates are going to be -4 and 4. Those are the endpoints. But do you see how I'm not even going to bother with -1. That's a local max. I'm not even going to bother with 1. That's neither because my derivative's not changing sign. So I've just cut some of the candidates, which cuts my time. How nice is that? And y'all, look. Did we not in letter A find G of 0? Yes, we found that to be 3/2. Did we not find G of 4? Now, again, in this case, now that I'm needing these values, I could type that in the calculator really easily and go, okay, that's 11. And what would G, so the only one that I haven't found is -4. Well, by golly, that's the easiest one there is. That's the easiest one there is because if you look, wouldn't my bounds be -4 to -4? So that would be equal to 0. So see how I did that so fast? Now, answer the question that was asked. Find the absolute minimum value of G. I want you to write a sentence. Absolute min of G on -4 to 4. That's important. They're very big about your interval. Now what's the question? Well, the value is 0. Okay? Great question. So what are the points? This was the first time that you talked about this, so you had to say how you're able to answer things about G when you're given the graph of F. So did you write that down there? I hope so. There was 1 point awarded for the candidates, and then there is 1 point for the answer. And again, that answer is with, wording and notation and interval and all that. So that was your 3 points for that guy. Good old candidates test. All right, part C. I actually didn't copy that down because I was like, I can just read that one. Part C says identify or something to the fact of find the intervals from -4 to 4 where G is concave down. Those curve sketching relationships, hopefully you don't even have to look them up. You already know. You say G is concave down when, again, the graph that was given is G prime. So you have to justify with G prime. G is concave down when G prime, now do you have to write this again? No, if you've written it in part B, you do not have to write that again, is decreasing. Therefore, my intervals would be, well, G prime is decreasing from here to here. That's why they told you where those horizontal tangents are, because I got to know the x value at that point right there. So decreasing from -2 to -1/2. It's also decreasing from +1/2 to 1. And it's also, that's why they told you that one was there, from 5/2 to 4. And so the point count, 1 for reasoning and 1 for all of the intervals. So reason and 1 for the intervals. So be careful when you're writing those. If you've got a negative, that would be unfortunate. Okay, I hope you got a lot of points on that one. Okay, that's a good one. I like him.